So I'm going to push the coin and then I press start.
I will play the note.
And then we have currently the ball here in the shooter. If I push the ball a little bit, it switches to the galloping sound. If the ball comes to rest again on the shooter, it comes back to the background music. So let's say that I shoot the ball, I catch the ball, and I'm going to show some of the different things that the machine does. Essentially the same thing as with the original Black Knight. We have the bonus here. The bonuses are, when we activate 2000, every time it goes through this little the in lanes, it's 5,000 when it goes on the outer the out lanes. Sorry, at this moment it's playing the sound that it should be playing when you try to catch the ball with a magnet and you lose. But let's show the targets, the drop targets. So we do have like the same type of response that we got in the original machine. Right? So we start. Obviously, if we drop the target before the timer expires, we get one arrow, and so on. We also have obviously the multi-ball function. This is the second ball, and we have the third ball. When we have the three balls, we have a multi-ball. At this time, we have the graphic screen showing the number 3 moving around. I'm going to keep these balls for a second, and then I'm going to show. So essentially, I keep shooting targets, and I keep getting points, whatever, until I get to the last ball. Then these all scores by 3, by 2. They were blinking when I have the multi-ball. Now they disappear. And then let's say that I keep pushing targets. The first time, boom, I get the animation with the whistle, and I get the extra ball light here. Its lit is in orange. So let's say that actually I realize the extra ball. In the original machine, the original Stevie Ritchie design, the animation, it's a little bit poor to my taste. I decided to do something a little bit different also to showcase that the machine has this design, although it's a copy of the original design, but it has a different personality. So let's say that I realize the extra ball. This is the moment that we have the ring telling you that you realize the extra ball, and obviously the shoot again, or fight again here at the bottom of the sword lights up. If I want to get another extra ball, obviously this time it's not enough with only 2 banks of targets. I will need to drop 4 banks of targets, obviously. This is just for show. And it's going to do the whole complete animation with all these different lights. And then of course we realize the extra ball, we're going to have the same animation. An interesting thing to show is if I complete 4 target banks again, now I get again the animation, and I get the second extra ball light turn on here on the U-turn. So let's say that I realize the extra ball on the U-turn. So I get the prize, I get the ring. I mean, the device is not connected yet, that's why it's not making that noise. And let's say I do the same thing on the upper side. So I get the animation again, which is just a colorful display. I chose to display all those colors. And after that, everything goes back to normal. So another thing that happens, and I'm trying to see, yes. So essentially we have the multiplier 2 times, because I passed the ball once here. I passed the ball a second time, now it's 3 times. Now it's going to be 4 times the bonus. Then it's going to be 5 times the bonus. And now it does a different animation. And this animation is similar to the animation the original machine does. What else? So I showed already the multi-ball. I showed the extra ball. Let's say multi-ball using 2 different balls instead of 1, instead of 3. Like for instance, I have the lock here. Now it turns solid. Before it was blinking. As soon as I have one ball in the upper lock, the multi-ball light on the hole on the lower playfield turns on. So essentially, if I shoot the ball here, what I'm going to have is a multi-ball now with two different balls, and I have the illumination of the multi-ball, but indicating that I only have two balls. Obviously, when I lose the ball, this blinking disappears. Okay. Obviously, when we have the ball coming on this side, we start blinking the 2500 when lit, and the mystery light is going to turn when I pass the ball on that side. Here, it turns on and then turns off. And what else? I'm going to show again the multi-ball, and this time I'm going to grab the camera and I'm going to show how does it look when you look at the back box. In this case, it's going to be mounted here. It's just, I am in the stages of development yet, but it's very close to finishing. So I'm going to show what happens, right? So we have the first ball in the lock. Now we have the second ball in the lock. And now we're going to throw the third ball in the lock, but I'm going to grab the camera and I'm going to switch to showing the display. Just to be stable. There you go. As you can see, it's blinking the same way that the original Black Knight blinks, because it's indicating that this is the moment that you have to throw the ball. It's showing you are the active player. If we had other players here, all the other numbers stay solid. This is the one that is blinking. If it was the second player, obviously we have the second player blinking, or the third or the fourth. In this case, we have only one player, so it's displaying that one. As soon as I make a point, look what happens. So now it changed the style of blinking to a waving style, and this is to indicate that if you lose the ball now, because it's score point, you lose the ball. If you lose the ball before scoring any points, which is the first case when it's blinking, then you don't lose the ball. But enough is enough. Let's go and show the multi-ball. I have two balls in the lock, and I'm going to insert the third one. So right now the playfield is turned off. There's no lights. It's blinking the same way the screen is blinking here, and the reason is I just caught a ball, two balls, sorry. One ball was lost. So the original three that you could see here that was moving around now turns into a two. And then what happens when I lose the ball? Boom, now it goes from multi-ball 2 to regular play. I'm going to do a multi-ball again so you can see how the numbers pop up. So I am about to put the third ball. So the three start populating and then they start moving. And now the machine starts throwing the balls. And there you have it. Multi-ball for 3 balls. And let's see what happens. Look at the bonus. When I start losing balls, right now I am at the maximum possible bonus. So I have another animation here. With the sound, everything is mimicking the original machine. And I think that because I had turned the extra ball before, I have the shoot again here. So anyways, so let's, I'm going to try and lose the ball so I can show you the other configuration, the screen when the game is over. losing balls. All right, so then I have game over. I'm just doing some debugging, so these two fields right now are showing flags, but actually that's very easy to remove and put the original variables here is actually the number of games, and this is the number of balls. And when the game is finished, it actually shows the 10, the 30, the 0, the 90, whatever is the match. I just happen to be debugging something. Anyways, so that is it. That's the Homebrew Black Knight. I'm going to add something else, which is I'm going to show the guts of the machine. So essentially, let me pull this up. I pull this up. I'm going to turn this off. And pulling this up, I created a mechanism so you can very easily roll the playfield. And if you have to work here, we have all the different components that you can see. So I think it's very difficult to see on this perspective, but with the exception of a few parts, everything that you see has been actually manufactured here at home. You think about, what about the flippers? What about the mechanism for the flippers? Well, yes, this has been manufactured here. All this is aluminum, with the exception of the prongs that I had to purchase. The core, was the name of the plunger. Actually, I purchased, but I did manufacture the coils. I did manufacture all these mechanisms. Here you have the kickers. These are brackets that I designed and I cut on my CNC machine and I bent using my sheet metal brake. LED lights on the playfield. These are the guys. These are little boards. Each one of these boards have 4, 3, or 2 LEDs 2812B that are actually excellent, individually addressable. So essentially, you only need one bit to communicate to a string of these LEDs. All the lights, all the animation that you saw on the playfield are actually made with 2812s. It's fantastic. Then these components, these are the drop targets. On this side, this is the lower bank. On the right, this is the left one. And this is not going to be very possible to show. I think it's very hidden. This is the other target banks. So most of these guys are 3D printed, with exception obviously of the metal core and the I don't know how to, the riser, I don't know. I mean, I don't know how to call them. It has the shape of a letter E and moves the target up when the coil resets them. I had also to cut these using my CNC machine. The 3D printed version wasn't really that good. This was mostly an exercise of exploration to see how far you could go using these things. Let's see if you can see here, this is the thumper bumper. It's a different color. This is orange. This is the very first thing I manufactured was the thumper bumper. And this is a bracket and it has all the mechanisms. I don't use a classic spoon sensor for the thumper bumper. It's electric contact based. It's a different type of sensor. All these drop targets have been realized using optical sensors. So they have it's a type of sensor that, oh, look that, we're lucky. We have one of them lying around. So this is the type of sensor. I think that the original equipment manufacturers, they use something similar. So essentially the drop target has a little bit of something that's like a fin. I don't know how to call it, or it's like a flange, I don't know. So when the target drops, it sort of cuts the flow of light between those two little towers. One tower has a transmitter, the other has a receiver, and when the change in the light is detected, well, you know that you have an event. As you can see, the magnets for the Magna Seo are not yet installed. I didn't get to that part yet. I haven't even manufactured the magnets. I do have the materials. Didn't have the time to put them together. Interesting is the through. As you can see, the through, there's not really any contact switches here. Everything are optical sensors. All these guys here are optical sensors. They detect the presence of the ball. They're called reflective sensors. Same thing with the in lanes and the out lanes, and everything that the ball has to be detected with all these notches that we have here in the bayfill are just for decoration. They were at some point in time used because I did explore using micro switches, came to the conclusion that using optical sensors was much more cost effective and they were much more reliable than mechanical switches. So I try to avoid everything that is mechanical if I can use something that is 100% electronic. What's next? So I have covered mechanisms, the hole ejectors, right? So this is the hole ejector, and I have another hole ejector for the locking mechanism. 90% manufactured at home. I only purchased the circular lever. It's like a thingy that moves out, pushes the ball. I didn't cut that using my machine. I have an acquaintance that had those laying around, so I asked him if I could use them. And what else? And that's pretty much it. The illumination is actually 12 volts. It's very bright. It's a little bit too bright. There are 3-watt lamps, each one, so I'm probably going to downsize it because it's extremely bright. And let's move to the electronic components. The core of the operation is Arduino Mega. It's a single board processor. There's actually a microcontroller. It's not a single board computer per se. It doesn't have an operating system, but it's very fast in comparison to using a regular computer because you're essentially programming in binary. I program in a language that is very similar to C, that is called processing, but it's super fast. And in order to be able to deal with real time, because all these events are real time, I use something called transition state machines. They are finite automaton. So, I mean, the issue is very complex. There's enough material to talk for hours about that. I'm not going to get into that. But as I was saying, this is the main brains of the device. The device connects with other boards that are called peripheral boards, slave boards, that are here. This is one, this is another one. I'm going to show close-ups as soon as I can. This is the third one, and we have another 2. Each one of these boards has basically 2 main functions. One of them is to control the solenoids. Each board controls 4 solenoids, and they are extremely modular. They talk to the AT Mega, the Arduino Mega, using a protocol called I2C, which is essentially a protocol that is used to communicate electronic circuits in the same board. So I kind of went a little bit, it was sort of a stretch to use that methodology of communication as a bus. But it saves money. I don't have to use R485 chips or any other type of networking chips or CAN bus chips. Somebody could say, yeah, but they are not as reliable. The truth is, yes, they're not as reliable. But in one of those reliable protocols, essentially what you send a message to your device, and the device is going to acknowledge to you, yes, I received the message. Using I2C is not so easy because you're going to be losing some bits because of the environment. So that kind of control to manage making sure that the package got to its destination, that issue is very easily solved. You send the message 3 times. There's literally no failure after 3 times. So it's, again, an exploration. It's a search for making things that work in an expensive way. So that's the control of the solenoids. That's one of the functions of this board. The other function of this board is to provide control for the general illumination. So it has an output, has 4 outputs that are 48 volts that you control the solenoids with that. One output which is 12 volts. 12 volts controls parts of the general illumination. You can control everything if you want, but you can also create segments inside the board, right? For instance, this board controls this segment of the general illumination. I have another board that controls another different segment or areas. And you can also use those 12 volts for controlling something else. If you have a shaker and you want to shake the machine every time that the horse is galloping, for instance, you can use that. I'm planning to do that, not done yet. So we spoke about the central processing, talking to these 5 modules. They generate outputs. Let's talk about inputs. So one of the biggest challenges when you have inputs is to make sure that the signal gets fast and clear to the processor. And that is accomplished using the advantage of the Arduino Mega. It has like 52 different bits input-output that I configure them as inputs. So, and I connect each one of those ports. I use RJ45 cables, the same cables that you use for networking, and they connect to these modules here. Okay, so here are an example of the module. This is a distribution module for the inputs. Anyways, there's much more to talk about this. This unit connects to the Raspberry Pi using a serial cable. So every time that there's an event here in the pinball machine, it tells the Raspberry Pi, make the sound 32, make the sound 15, stop making the sound whatever. So there's a constant dialogue between the two computers, the main computer, the rule processor, and the display processor and sound processor. That's pretty much it. So I'm going to try and show some close-ups. And these are the boards that I designed. I don't know if you can see much, but essentially this little guy here is a Arduino Mini. It's called Arduino Mini. It's a very small microcomputer. These are the two communications for the I2C network. And here on this side, you can see these are the connections for the solenoids. Each one of these guys is a connection for a different solenoid. And the other thing that I forgot to mention that they have one port. Each one of these 5 guys has one port and controls a strip of LEDs 28, 12. And the reason that I have 5 controlling instead of 1, I could control this with 1 bit, but you want them to be fast, okay? So instead of having 1 line of control, I have 5 lines of control. And I do everything sending messages on I2C. I tell them I want to turn on the LED number 12. So there's a message that I programmed, which is an I2C message. It goes to this little processor, and this little processor takes control of that. So, and that's pretty much it. Let's go to the other display, the other computer. So here is, I'm going to show, this is in the stages of development. No, it's not. Okay, I have a fan that is cooling the Raspberry Pi. So this is the little thingy that is showing, where is it? There you go. This is the Raspberry Pi. That little thing is controlling the display and producing the sounds. So some other things interesting to show are the machines that I use. I apologize for the mess right now, but voila, this is a CNC machine. It's built also entirely at home. So we have the X, Y, Z controls, and there's a distance end here that goes. Where is it? That yellow thing is a router. It's a different kind of router. And I control XYZ of that movement, and I can use in this example, I just cut a number 0 for a house. I have a friend that it's moving, so he asked me to cut some numbers for him. And this is the coiler machine that I put together. With this machine I make the coils. Interesting thing. Okay, so that's it, and I hope that you enjoyed the video. It's just a demo. There's hours and hours to talk about this, and unfortunately there's no this is 25 minutes, but at least to give you an idea how this is done, right? So thank you very much and have a good day.